By the end of this lesson, students will be able to describe the bonding and acid-base nature of the oxides of group 14 elements, describe the relative stabilities of the oxides of group 14 elements, and their aqueous cations. The dioxides of the group 14 elements are as shown. GeO2 is amphoteric. Click the plus alkali button. Now, click the plus acid button for the reaction with concentrated acid. Drag and drop the buttons into the empty boxes to indicate the acid-base nature of these oxides. Carbon dioxide is a simple covalent molecule, while silicon dioxide is a giant covalent molecule. Click CO2 and SiO2 to view their structures. Click Bonding. The bonds in GeO2, SnO2, and PbO2 have both covalent and ionic character. The ionic character of the group 14 dioxides increases down the group. All the elements of group 14 form the monoxide MO. CO and SiO are neutral, while the other monoxides are amphoteric. Click SnO and PbO. Summary. Group 14 elements form the monoxide MO and the dioxide MO2. On descending group 14, the bonding changes from covalent to ionic. The dioxides change from acidic to amphoteric. The monoxides change from neutral to amphoteric. Click on each of the empty blue boxes in the table. CO, SnO, and PbO are all stable to heat. Click on CO to find out why it is stable. SiO and GeO are unstable. Click on GeO to find out how it reacts when heated. GeO disproportionates when heated. Now, click on each of the empty pink boxes. All group 14 dioxides except PbO2 are thermally stable. Click PbO2 to view its decomposition products. When heated in air or oxygen, all the monoxides except PbO are oxidized to dioxides. Click the more stable oxide of each element. As a consequence of relative stabilities, the reducing strength of the monoxide decreases and the oxidizing property of the dioxide increases down the group. Click Remarks. Summary. The monoxides of carbon, tin, and lead are thermally stable, whereas the monoxides of silicon and germanium are not. With the exception of lead, group 14 dioxides are thermally stable. Group 14 dioxides are more stable than their monoxides. Group 14 monoxides can be oxidized to dioxides. Carbon, silicon, and germanium do not form simple cations. Now, click on Sn and Pb. Click on the more stable cation of tin and lead. Sn4+ and Pb4+ ions are unstable in aqueous solution. Sn2+ ion is less stable than Pb2+ ion in aqueous solution because the inert pair effect is more significant in Pb2+ than Sn2+. Summary: carbon, silicon, and germanium do not form simple cations. Sn4+ and Pb4+ ions are unstable in aqueous solution. Sn2+ ion is less stable than Pb2+ ion in aqueous solution.